Okay, continuing our study of fractions, we're simplifying fractions. We're putting fractions in the simplest form. We have a larger fraction here, 75 out of 100, or 75 100ths. This is not in the simplest form. And the reason we use simplest form is because it's usually a little bit easier to communicate, a little bit easier to visualize and understand exactly what it's talking about. 75 out of 100 isn't hard for most of us because we understand dollar, quarters and dollars, stuff like that. It's a little bit easier fraction to understand. We're going to reduce this one anyway. The next example I'm going to show you will be a better example of why we reduce. It's not just because teachers want to be a pain. It's because when you communicate mathematics, you need to put it in the most understandable form possible for the person reading it. So that's why. Now, the process I showed you in the last video was to list multiples and then find the largest multiple they both have in common. That's the primo way to do it. That's the way most teachers are going to teach you. What I'm going to show you here is a little bit of a hack with larger numbers. This is a personal feeling. I think it's easier with larger numbers as you get to understand the dynamic of numbers better to kind of start reducing, instead of listing all the multiples, just start reducing by multiples you quickly see and are aware of. I think it ends up being faster in the end most of the time. Some teachers might disagree with me, and if so, they're not going to let you watch this video. They're going to have you do it the other way. So just keep that in mind. So here's Turner's hack to reducing large numbers. Instead of listing multiples, I'm just going to look at this and see if I can quickly identify a multiple that I know they have in common. In other words, something that they'll both divide by. And I know that they'll both divide by 5 because this ends in 5, this ends in 0. And if that's the case, then they will always divide by 5. So that's a quick and easy hack. And since I'm dividing by 1, that's key, top and bottom by same, perfectly legal maneuver. 75 divided by 5 is 15. These factors are a little bit harder. So you may need a chart, or you may need there's charts of multiples that your teachers can give you to help you a little bit with this. Or maybe they'll let you use your calculator to do this part. Or you may have to come to the side and just divide. You really may have to just come over here and do 75 divided by 5 to get to the 15. And if so, that's what you have to do. I'm not going to demonstrate that part because I know you know how to do that part. 100 divided by 5 is 20. So we've got a simplified version of that fraction, but is it as simple as it can get? We need to check, because when you use this Turner hack, you don't always get it completely on the first try. In fact, usually you won't with larger numbers. So I need to check again, is this in simplest form? And I can see right away again that these are both divisible by 5. So I'm going to go one more time by 5. Because this ends in 5, this ends in 0, so I know that's a divisibility test by 5. I can reduce them both by 5. So again, dividing by 1 makes this a legal move. 15 divided by 5, that's one we probably know, is 3. And 20 divided by 5 is 4. Now, since we're doing the hack, we need to look again, is this in simplest form? This is pretty easy to see that it is, because 3 and 4, I can't take those any lower. I can't reduce them anymore. There's nothing that they both divide by that'll come out as a whole number. I'd end up with decimals over fractions, which is a mess. So I'm done simplifying that fraction. Now let's do one that's a little more complicated. And I would say simplification of fractions is one of the more complicated things in math, so don't be worried if this takes you a long time or if it's really hard in the beginning. You'll get it, you'll get better at it. You just have to do a lot of them, and that's the hard thing with math that nobody really wants to hear, is you just have to practice. There's really no magical way that this is going to become completely obvious to you. It just takes a lot of practice. Now, if you're better at retrieving your facts, you'll be a little faster at it than someone who's not. There are little nuances to it, but it's just going to take a while. So let's use the Turner hack, large number again. I want to look and see 36 and 90. I know they're not both divisible by 5 because this doesn't end in 5. So that won't work. So my next easy one is 2. They'll both divide by 2 because they're both even. So that's an easy divisibility test. Divide by 2, they're both even. Since I'm dividing ultimately by 1, 2 over 2, this is a legal move. 36 divided, because I'm not changing it. Multiplying, dividing by 1 doesn't change it. Just puts it in a more simplified form. 36 divided by 2 is 18. 90 divided by 2 is 45. Again, this is a more difficult fact to retrieve, so you may actually have to come to the side, then take 90 divided by 2, go through your steps for multiplication, and end up with 45. If so, that's just what you have to do. Eventually you're going to get better at this and you won't have to do that anymore. But you might have to do that in the beginning. Don't feel bad if you do. It is going to take you a little bit longer. Can't lie to you about that. Now since we did the hack, we may not have gotten it right the first time. It may simplify a little bit more. Now, we know the 5 won't work because this isn't a multiple of 5 or 0. We know the 2 won't work because they're not even. So now we have to get the more obscure numbers and the divisibility rules. That could be another lesson your teacher may have gone over with you, are a little bit harder. This one I just happen to know is divisible by 3. Both of them. One test for divisibility by 3 is when you add these two digits, 8 plus 1 is 9. That's divisible by 3, so the whole thing's divisible by 3. 4 plus 5 is 9. 9 is divisible by 3, so therefore 45 will be divisible by 3. Just a quick review of divisibility rules. Any rate, they both divide by 3, so again, that totals 1, perfectly legal move. 18 divided by 3, that one's actually going to be on a multiplication table, so look it up if you don't remember it. 45 divided by 3 is 15. May have to go over to the side to work that one. If I did, just do a little quick division problem. 3 goes into 45, and you'd end up with 15. Now let's look again one more time. 6 out of 15, is it in the simplest form? And here's where, in this case, the hack may not be any faster than listing the multiples, but I'm telling you there are a ton of multiples to 90, so it's also not any slower. If I look at 6 and 15, I probably am going to be able to quickly see these are both divisible by 3 again. So I can go one more move. 6 divided by 3 is 2. 15 divided by 3 is 5. And that is going to be my most simplified form because nothing goes into 2 and 5. There's no number that goes into both of those. Now I might have here recognized too that they're both, let's just stop. So we know we have a right answer. Well, let me show you something else that could have happened. And I know this is a lot. Really, we're getting into the more complex aspects of math with this. So your study of math's getting pretty sophisticated right now. I might have noticed also that right here, both of these are divisible by 9 because I just know the multiples of 9. 9 times 2 is 18. 9 times 5 is 45. So I can divide both by 9. And you see, I would have, if I'd have recognized that, I would have gotten to my answer a little bit more quickly. I would have saved this step. And you might have noticed that here. 36, 9 times 4 is 36, 9 times 10 is 90, so you might have noticed that right away too. There's a lot of different ways this problem could work out to find the same solution. But if you use the hack, you just keep whittling away till you get it to a place where you just can't whittle anymore. And there's a lot of nuance to that. There's really a lot of complexity to that. I'm not going to lie to you and say this is an easy aspect of math. It's not. It's a part of math you're going to have to practice a lot in order to get really good at it. So, in the spirit of that, let's jump to some practice.